Welcome to the deep dive. You know, sometimes you want to really get your hands dirty and prove you can actually do something, right?
Mhm.
That's kind of what the EX248 exam for Red Hat OpenShift is all about. It's a practical gauntlet.
Definitely. Tests real skills.
Exactly. Now, we're not here to grill you on specific exam questions, but our mission today is, well, I think it's way cooler.
Yeah.
We're going to pull apart the kinds of real-world problems that someone aiming for this certification or, frankly, anyone serious about mastering OpenShift actually wrestles with.
Exactly. We've lined up a series of scenarios, straight from the trenches of practical OpenShift admin.
Right.
Forget abstract theory for a moment. We're going to dissect concrete examples of how you configure different parts of the server environment and handle those everyday management tasks. The stuff that keeps applications running smoothly on this platform.
That's it. So whether you're plotting your path to that EX248 badge or you're just driven to understand the nuts and bolts of OpenShift, consider this your backstage
Yeah.
pass. We're aiming for those like light bulb moments by showing you these configurations actually in action. Okay, let's dive into our first challenge, setting up server groups.
So the initial task, it throws you into configuring a new server group. They want it named core group.
Okay, core.
Now, this isn't just creating an empty container. You also need to assign a custom core profile to it.
Yeah, a custom profile.
And then the real kicker,
Yeah.
you've got to add two specific servers, server 1 from host 1 and server 2, well, server 2 living on host 2, into this brand new group.
Okay, so at a high level, why even bother with server groups? What's the underlying benefit of organizing servers like this?
Well, think of server groups as your way to bring order to potentially chaotic deployments, really.
Okay.
They give you a logical structure for managing your application servers collectively. This allows for, consistent configuration.
Ah, consistency.
If you tweak a setting at the server group level, it just applies to all the servers within it. Simple as that.
And the custom profile, .crow file.
That's where you get really granular. You can tailor specific settings, maybe memory allocations or specific internal services that are just right for your quality assurance environment.
So specialized teams of servers.
Exactly. With their own distinct operational guidelines. It's about having specialized teams, yeah.
That makes total sense, like organizing different departments within a company, maybe? Each with its own policies.
Precisely.
Now, the example specifically points out that these servers are on different hosts. Is there something significant we should take away from that?
Yeah, what's really interesting about the multi-host aspect is that it immediately highlights the distributed nature of modern apps, right?
Okay.
Server groups aren't confined to a single physical machine. That's fundamental for building applications that can handle more load and stay resilient if one host goes down.
Right. Resilience,
Uh,
distributed systems.
And think about it deeper. Server groups simplify applying resource quotas or network policies across different hosts, too.
Yeah.
Finer control.
Right. And the final piece of this first task is actually starting those servers and then proving they've joined the COG group, like CLI or web console.
Mm-hmm.
It's not just setting it up. You've got to show your work, right?
Okay, absolutely. Validation is the unsung hero here. Seriously.
Yeah.
It's not enough to just issue a command and, hope for the best.
Yeah.
You need proof, concrete proof, that the system is in the state you intended.
Verifying the group membership.
Exactly.
Sure.
Make sure your config was applied correctly, and those servers are now managed by core group.
All right, let's move on. Deploying applications. Scenario 2 asks you to take a testapp.war file
Yep, standard war file.
and get it running on both a web group and our new core group, all from the command line.
Yeah, this one shows a really efficient way to handle deployments, especially with multiple environments.
Like dev, QA, prod.
Exactly, or different tiers.
Mhm.
Instead of repeating the deployment for each group, you target them simultaneously.
Saves time, I bet.
Oh, saves a significant amount of time. And it helps ensure consistency. You're deploying the exact same version everywhere it needs to go.
Consistency again. And what about like making sure QA looks like production? Environment parity.
That's a great point. Deploying to multiple groups really helps with that. And you can even use it for things like canary deployments or blue-green rollouts,
Gotcha. So it's like having a central dispatcher saying, okay, testapp.war, go here and here.
Pretty much, yeah.
Now, how do you actually confirm that it landed correctly in both spots?
Well, the task emphasizes confirming the app isn't just there, but that it's actively running and enabled on all servers in both groups.
Running and enabled.
Right. And beyond that, it specifically mentions digging into the server logs, checking for any deployment hiccups.
Oh, the logs again?
A clean deployment means, files transferred okay, app started without errors, it's properly integrated, No surprises.
That focus on CLI and logs feels very practical, not just clicking around a GUI.
Exactly.
Yeah.
In the real world, automation is king, right? And the CLI is scriptable, powerful for scale,
Makes sense.
and checking logs. That's just fundamental. It gives you that detailed, under-the-hood view. Absolutely crucial for troubleshooting when things inevitably go sideways.
Okay, next up, we're talking security, HTTPS. This question involves setting up an HTTPS connector using a key store on a single server.
Yep, standalone server config.
It mentions bringing in an SSL certificate, configuring something called a security realm, and making changes to the undertow subsystem.
Oh, yeah.
It's like a few interconnected steps.
It is indeed, but these are totally foundational steps for securing any web-facing application.
Okay.
The first part, inputting your SSL cert into a Java key store. That's essentially managing your server's digital identity.
Like a passport.
Exactly. Like a digital passport, verifying who your server is to clients connecting to it.
And the security realm, what exactly is its job in all of this?
Security realm is where you define how users or maybe other services are authenticated.
How they prove who they are.
Right. And authorize what they're allowed to do once they're authenticated. It's a security layer, sits between incoming requests and your application.
Like a bouncer at a club.
Yeah, perfect analogy. Checking IDs before letting anyone in.
Okay. And then we have to create an HTTPS listener within the undertow subsystem. What is undertow here, and what does a listener do?
So undertow is the underlying web server component in this setup. Think of it as the engine powering the web server part of OpenShift.
The engine. Got it.
And a listener. That tells the web server to actively listen for incoming network connections on a specific port using a specific protocol.
So HTTPS in this case.
Exactly. By configuring an HTTPS listener in undertow, you're telling it. Accept secure connections over HTTPS, encrypt the communication, protect that data.
And it mentioned editing standalone.xml.
Yep, that's typically where these core server configs live.
And finally, the task says restart the server and try accessing it via HTTPS. That validation step again, clearly important.
Absolutely essential. You need to confirm all these pieces, cert, realm, listener, are working together harmoniously.
Checks everything's wired up right.
Testing with an HTTPS request verifies the cert is installed and trusted, the realm's active, and undertow is handling secure connections correctly.
Makes sense. Maybe we should also think about things like certificate chains or TLS termination for performance.
Oh, good points. Definitely deeper topics, but yeah, very relevant in real-world HTTPS setups.
All right, let's talk about keeping an eye on things. The next question is about turning on access logging for undertow.
Yep, web subsystem logs.
It mentions setting up a custom log pattern and deciding where these logs should be stored. Why is all this logging so critical?
Access logs are like the black box recorder for your web server. Seriously useful.
Clockbox. So
They give you a detailed record of every single request that comes in, who accessed what, when, where from, the server's response. Invaluable stuff.
for monitoring, debugging.
All of the above. Monitoring activity, diagnosing problems, security analysis to spot weird behavior, even debugging application issues.
And why go to the trouble of a custom log pattern? Isn't the default usually okay?
The default might be fine sometimes, but custom patterns give you the power to capture exactly the info that's most relevant to you.
Tailored info.
Right, in a format that maybe integrates better with your analysis tools or just makes more sense to you. You might want processing time, specific headers, user agent, stuff not in the default.
And choosing the location. Obvious, but important.
Yeah, you need them somewhere accessible, manageable, and where they fit your retention policies. Don't want logs filling up the root drive.
The validation here is straightforward. Make some HTTP requests, then go look at the log file, see if they're recorded.
Exactly. Direct test. Is logging working as expected?
Verifies the config is active and capturing what you need.
Yep. Seems simple, but saves countless hours later when you really need to trace something.
Our fifth scenario takes us into databases. We need to configure a data source named inventory DS,
Okay.
connecting to a PostgreSQL database. This involves the JDBC URL, the driver class for Postgres, username, password.
Standard connection stuff.
And we can do it via CLI or XML, plus enable statistics and test the connection. Quite a few pieces.
It is, but getting that robust, reliable connection between your app server and your database is, well, absolutely fundamental for most apps.
True.
The data source config acts as an intermediary, provides a standard way for apps to talk to the DB without handling low-level connection details every time.
And connection pooling, is that part of this?
Often is, yeah. Configured in the data source, huge performance impact by reusing connections instead of creating new ones constantly. Definitely something to think about.
Okay. For listeners maybe newer to this, could you quickly explain the JDBC URL and the driver class? What do they do?
Sure, the JDBC URL, Java Database Connectivity URL, is basically the address of your database server.
Like a web address, but for the database.
Sort of, yeah.
Yeah.
Tells the app server the host, the port, the specific database name, where to find it.
And the driver class.
That's a piece of Java software. A translator. It knows how to speak the specific language of your database Postgres, in this case.
Ah, the translator.
Allows the app server to communicate effectively. You need the right driver for your specific database type, like needing the right adapter plug for a different country.
Good analogy. And the task mentions CLI or XML editing. Pros and cons?
Well, the CLI, the command line, it's more dynamic, often scriptable, great for automation, setting up data sources consistently across environments,
Scriptable. Okay.
editing XML directly, more static, sometimes gives a clearer view of all settings in one place.
So preference, or depends on the task.
Often boils down to preference, the task, and yeah, whether you're automating or just doing a one-off config.
Enabling statistics and actually testing the connections seem really important before using it. Why?
Enabling stats gives you valuable insights into connection usage, how many are active, request times, any connection issues. Super useful for tuning.
And the test.
That's your fundamental sanity check. Confirms all parameters, URL, user, password, driver, are correct. Confirms the server can actually reach and log into the database.
Prevents headaches later.
Exactly. Stops a lot of runtime errors before they even happen.
Moving back to security. Next question. The management interface.
Ah, yes. Securing the admin access.
We need to configure user authentication using a mgmt-users.properties file, add at least 2 admin users, and then verify login. Why is securing this interface such a high priority?
Because the management interface provides administrative access. It's the keys to the kingdom, really.
Keys to the kingdom, right?
If it's not properly secured, unauthorized folks could make critical config changes, deploy bad apps, even, take complete control. Authentication is your absolute first line of defense.
Crucial. And using a simple properties file seems straightforward. For managing users here.
It is. It's simple, common, especially for smaller setups or initial configuration.
What are the key things to watch out for?
Well, the security of the file itself. Got to have the right permission so only admins can read or change it.
Makes sense.
And, for bigger, more complex places, you'd probably integrate with LDAP or Kerberos, more robust identity systems.
But the properties file is a start. And why 2 admin users?
Ah, that's a critical best practice. Redundancy. Ensures access isn't tied to one person. Prevents a single point of failure for admin tasks. What if someone's on vacation or leaves?
Good point. The validation is obvious. Try logging in with the new users.
Yep. Simple check. Can you get in? If yes, auth is working. If not, double check the config. Immediate feedback.
Our 7th scenario dives into role-based access control, RBAC.
Yes. Important concept.
The task is to create a custom role deployer with limited permissions, just for deploying apps.
Okay, specific role.
Then assign a user to it and test the permissions. Deployment should work, but server shutdown should fail. Why is RBAC so fundamental?
RBAC is just a cornerstone of secure system admin. It's all about the principle of least privilege.
Least privilege, only give permissions needed for the job.
Exactly. Grant users only the absolute minimum permissions they need. Defining roles with specific permissions, assigning users to them. It significantly limits the potential for accidents or malicious actions.
Or reduces the blast radius if something goes wrong.
Precisely. And think about compliance, too. RBAC gives you clear audit trails. Who has permission to do what?
So in this case, the deployer role lets someone push apps but not shut down the server.
Exactly that. That granular control is what makes RBAC so powerful. Tailor roles to specific responsibilities.
And the validation confirms it works.
Right. The task requires you to prove the deployer user can deploy, but gets blocked from shutting down the server. Direct testing confirms the RBAC policies are actually enforced.
Now we're tackling log files again. But managing them, question 8, configure log rotation.
Keeping those logs under control.
For the server logs, using the periodic rotating file handler, goal.max, 10 log files, each capped at 5 megs, using max backup index and rotate size. Why is rotation so crucial?
Because without it, logs just grow forever, right? Eat all your disk space, make finding anything impossible.
Yeah, seen that happen.
Log rotation automatically archives or deletes older logs based on criteria like size or age.
Yeah.
Keeps things manageable, makes troubleshooting feasible.
And what exactly do max backup index and rotate size control?
So max backup index sets the max number of old log files to keep, here set to 10. Once you hit 10 rotated logs, the next rotation deletes the oldest one.
Keeps history, but limits it.
Right. And rotate size, that's the max size a log file can reach before it rotates. Here, 5 MB. Hit 5 MB, close it, archive it, usually rename it, start a new empty one.
Okay, that's clear. The validation step makes perfect sense. Generate enough log data to force rotation. Then check that old logs are archived correctly. See it in action.
Exactly. Verify rotation happens based on your settings.
Yeah.
New files created, old ones archived. Total number capped by max backup index. Keeps things tidy, prevents disk issues.
Our penultimate scenario, clustering.
Fun stuff. Node discovery.
We're tasked with setting up how nodes find each other, using DNSPNE instead of the default TCP/PANE.
Okay, switching discovery protocols.
Yeah.
In the JGroups subsystem.
Need the right DNS name listing the cluster members, and then verify the cluster actually forms after restart. What's the basic idea behind node discovery?
Well, in a cluster, you have multiple servers working together, right, for high availability performance.
Like a team.
Exactly. Node discovery is how these individual servers, the nodes, find each other on the network, how they connect to form that cohesive cluster, that team. Without it, they're just isolated servers.
And why use DNSPANE over the default TCP/PANE? What's the difference? Potential benefit.
Okay, so TCP/PN often uses a static list of IPs or host names or maybe network multicast. Can be a bit rigid.
Right.
DNSPNE uses DNS, the domain name system, to look up the IPs of the members. This is really good in dynamic environments.
Like the cloud, where IPs might change.
Exactly. Or where you want a central place, DNS, to manage the list of nodes. Update the DNS record, nodes get added or removed dynamically. No need to reconfigure each server individually.
Ah, much more flexible for scaling or cloud setups.
Definitely. Often integrates much better with those dynamic infrastructures.
So the task, modify JGroups config, swap TCP/PANE for DNSPNE, point it to the right DNS name, and the critical validation.
Restart the nodes and see if they actually form a cluster.
That really confirms it's working.
Absolutely. Successful cluster formation with DNSPAN validates your DNS config is right. Servers can query it, get the peer list, and connect. Vital for cluster reliability.
Finally, our last scenario, server suspend mode.
Okay, graceful maintenance.
Configure and test this for server 1 using the CLI. Goal: prevent new sessions during maintenance, but let existing ones continue. Then resume the server. Check logs for suspend resume events. Why use suspend mode?
Suspend mode is a super useful operational tool. Lets you do maintenance or upgrades without just abruptly kicking everyone off.
Less disruptive.
Much less. Put a server in suspend mode, it stops accepting new connections, new sessions.
Yeah.
But it gracefully allows users already logged in with existing sessions to keep working until they log out or time out.
Smoother way to take a server offline.
Yeah, especially combined with a load balancer. You can pull individual servers out of rotation for maintenance. Users barely notice.
So it's like putting up a "we'll be back soon" sign, but folks already inside can finish their shopping.
Ah, perfect analogy. Yes.
The task emphasizes using the CLI, checking that new sessions are blocked, existing ones aren't, then resuming brings it back to normal.
Exactly. The validation is crucial. Confirm suspend blocks new sessions? Check. Existing users unaffected? Check. Resume brings it back online fully? Check.
And the logs provide the audit trail.
Yep. Reviewing logs for suspend resume events confirms that state transitions happened as expected. Good for auditing, troubleshooting later if needed.
Well, that was a truly comprehensive.
Deeper into undertow for web server tuning.
Or exploring JGroups more for high availability.
Could be. And it's definitely worth pondering how some of these manual config tasks, how they could be streamlined, automated even in your own environment.
Ooh, automation. That's a whole new layer of efficiency.
Exactly. And maybe a topic for another deep dive down the road.